Today we are going to discuss about various types of hardness, what are the drawbacks of using hard water and how to remove the hardness of water. Now we know what is meant by hard water. The types of hardness are classified into two types. One is called temporary hardness and another one is called permanent hardness. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium. So, if calcium bicarbonate or magnesium bicarbonate are present in water, it will impart temporary hardness. This type of hardness can easily be removed by exposing to air or by boiling. That is why this type of hardness is called as a temporary hardness. But if the water consists of soluble chlorides and sulfates of calcium and magnesium, then the resultant hardness is called as a permanent hardness. It is so called because it cannot be removed by the simple process of boiling or exposing to air. Now, what are the drawbacks of using hard water? Hard water as it is cannot be used either for drinking purpose or for cultivation purpose or for industrial applications. Hence, hard water has to be converted into soft water, because in nature most of the water available is in the form of hard water only. So, how we can remove the hardness of water? Various methods are used for this purpose. Let us see one by one. Methods used for the removal of hardness of water. The following methods are commonly used, like boiling, Clark's process, soda process, Colgan's process, permutate or zeolite process, ion exchange method. This ion exchange method is also called as a resin method. Now, boiling method. As the name indicates, in this method the hardness of water is removed by the process of boiling. The limitation of boiling method is it can remove only temporary hardness but not permanent hardness. On boiling, water containing soluble bicarbonates of calcium and magnesium, they are converted into insoluble forms and hence the hardness is removed. One more drawback of boiling process is only limited quantities of water can be treated by this method, as with increase in the quantity of water, energy requirements for the process also increase. Clark's process. In this process, milk of lime is added to remove the hardness of water. Chemically speaking, calcium hydroxide is called as milk of lime. When it is added to water, being sparingly soluble, a small quantity gets dissolved and the dissolved part will be ionized to calcium ions and hydroxide ions. The hydroxide ions released will combine with hardness causing calcium and magnesium ions present in water and convert them into calcium hydroxide and magnesium hydroxide, which are sparingly soluble and will come out in the form of white colored precipitates. So, in this process, both temporary and permanent hardness can be removed. However, the limitation is to remove the hardness, we are adding milk of lime, which will release calcium ions, which will again impart hardness to water. That is why it is not a suggested method for the removal of hardness of water. Colgan's method. Colgan is the name of the chemical used to remove hardness of water. Colgan is chemically Na2Na4PO3 taken 6 times. The chemical name of colgan is sodium hexametaphosphate. It is an example for complex compound. The sodium ions present inside the complex sphere can be exchanged for calcium and magnesium ions. So when calculated quantities of colgan is added to hard water, the soluble calcium and magnesium ions are converted into complex ions, and in that process their natural tendency to impart hardness to water will be lost. In that way, hardness of water can be removed. This method is suitable for the removal of hardness of limited quantities of water, and the reactions involved are: colgan can interact with 2 moles of hardness causing ions and converts them into soluble complexes. In this way, hardness is removed. This product is called sodium calcium hexametaphosphate, and the other one is known as sodium magnesium hexametaphosphate. Both these are soluble complexes. As long as calcium and magnesium ions reside inside the complex sphere, they will lose their natural properties. In that way, hardness of water, both temporary and permanent, can be removed by this method. Soda method. In the language of chemistry, 2 substances are named as soda. One is sodium hydroxide, another one is sodium carbonate. Sodium hydroxide is known as caustic soda, while sodium carbonate is called as washing soda. When these substances are added to hard water, they will convert soluble calcium and magnesium ions into corresponding insoluble compounds. In that way, hardness is removed. When caustic soda is added to hard water, the calcium and magnesium ions are removed in the form of their insoluble hydroxides. Whereas when washing soda is added, the soluble calcium and magnesium ions are removed in the form of their insoluble carbonates. In this way, both temporary and permanent hardness of water can be removed. In between sodium hydroxide and sodium carbonate, the better option is sodium carbonate, because sodium hydroxide has a corrosive effect on the skin. That is why it is called as a caustic soda. Hence, in most of the detergent powders, sodium carbonate is used up to a composition of 80%. The purpose of using detergent powders is to decrease the hardness of water. Soft water can clean the clothes on its own. So, the efficiency of detergent powder depends on its ability to decrease the hardness of water. Permutate or zeolite method. A naturally occurring compound, sodium aluminum orthosilicate, is called as permutate. When it is prepared artificially in the laboratory, then it will be called as zeolite. In this part is inert in nature, while the reactive part is sodium ions. For convenience purpose, the inert part is represented with the symbol Z. When hard water is made to pass through this permutate, calcium and magnesium ions will be trapped by the inert part and sodium ions are exchanged for calcium and magnesium. So you get calcium zeolite, magnesium zeolite. In turn, sodium ions are released into water. In this way, both temporary and permanent hardness of water can be removed by using permeate or zeolite. The permeate, when it is completely converted into calcium or magnesium zeolites, becomes inactive in nature. The completely converted calcium or magnesium zeolites are called as exhausted permeate. This exhausted permeate can be regenerated by washing with a brine solution. Brine is a 10% concentrated salt solution. When calcium or magnesium zeolites are treated with a brine solution, the reverse process will take place. Sodium ions of the brine solution will replace calcium and magnesium ions. So again you will get back sodium zeolite, which can be reused again and again. The actual process can be schematically represented like this. This is a schematic representation of a permeate process. This essentially consists of a tank-like structure in which on the top another tank is provided that stores brine solution, that is 10% concentrated salt solution. The second one, which is visible in the diagram, it is a pre-filter. It will remove any insoluble content in the water. The third part represents the storage space for hard water. Below the hard water, you can see permeate. Permeate is a porous solid substance through which water can trickle down, and in that process the calcium and magnesium ions are filtered off and will be replaced with sodium ions. The resultant water is made to pass through gravel, which is a natural filtering agent. Soft water is collected at the bottom of the tank, which can be collected as per the requirement. Whenever the permeate is exhausted, the inlet for hard water is closed and outlet for brine tank will be opened. The brine solution, it will interact with the permeate, exhausted permeate, convert it back into sodium permeate that can be reused again and again. Hence, this method is most economical and efficient method for the conversion of hard water into soft water. Particularly, this method is used in laundries for the conversion of hard water into soft water. This is the schematic representation of ion exchange method. In this ion exchange method, water is made to pass through two chambers. One is called cation exchanger, another one is called anion exchanger. As the name indicates, in the cation exchanger, all types of cations present in water will be replaced, and in anion exchanger, all the anions are replaced. Hence, the water coming out from the second chamber is free from all types of cations and anions. Hence, the water purified by this method is called as deionized water or demineralized water, as it is free from all types of dissolved content. This method can be used for the conversion of saline water into drinking water, because in any other method only calcium and magnesium ions are removed, but not other types of ions. In this method, all types of cations and anions are removed from water, and hence even the taste of water also can be changed. Now, how it works? The cation exchanger consists of resins called acidic resins. These acidic resins will remove all the cations present in water and replace them with H plus ions. In the anion exchanger, basic resins are placed which will remove all types of anions present in water with OH minus ions. Hence, the coming water from the second chamber is a pure form of water. The cation exchanger and anion exchanger can be regenerated by using dilute sulfuric acid and dilute sodium hydroxide solutions. Dilute sulfuric acid will regenerate exhausted acidic resin, while sodium hydroxide solution can regenerate exhausted basic resin. The reactions involved can be explained in the following manner. Ion exchange method, also called as resin method. So, as we have seen in the diagram, in this method, first water to be purified is made to pass through cation exchanger. The cation exchanger consists of acidic resins that can be represented with the general formula RCOOH. In this, RCOO part is inert in nature, while H part is mobile in nature. When cations enter into the cation exchanger, a general cation can be represented with the formula M plus N. Depending on the magnitude of charge it carries, equivalent moles of the resin will interact, and the cation is replaced with the equivalent number of H plus ions. Once the acidic resin is completely converted into cationic resin, that is called exhausted acidic resin. This exhausted acidic resin can be regenerated by washing with dilute mineral acids. Above the cation exchanger, we can see a tank containing dilute sulfuric acid. The exhausted resin, when it is treated with dilute sulfuric acid, H plus ions present in the sulfuric acid will convert the exhausted resin back to acidic resin, and in that process the trapped cations will be released. This is the reaction involved in the regeneration of acidic resin. Similarly, when the water coming out of the cation exchanger is passed through anion exchanger, in the anion exchanger basic resins are present that can be represented with the general formula RNH2OH. In this, RNH2 part is immobile in nature, while OH part is mobile in nature. When an anion enters into anion exchanger, a general anion can be represented with the formula A power minus n. Depending on the magnitude of negative charge, equivalent moles of the resin will interact and will replace the anion with the equivalent number of OH minus ions. The H plus ions released in the cation exchanger, OH minus ions released in the anion exchanger will combine together to give water, and the exhausted basic resin can be regenerated by washing with dilute basic solutions. In general, sodium hydroxide solution will be used. This reaction takes place during the process of regeneration. The OH minus ions of sodium hydroxide will release the anions trapped in the basic resin, and in that process again the exhausted resin is converted back into basic resin, and which can be reused again and again. These are the chemical reactions involved in the process of ion exchange method. Heavy water. It is also called as deuterium oxide D2O. We have to see its preparation methods, properties and uses. Heavy water is present in natural water in trace quantities. Hence, it has to be isolated from natural water itself. The process used is called as Urey's exhaustive electrolysis method. In this method, a large steel tank of capacity 6000 liters will be used as a cathode. A perforated nickel ladle is placed that acts as an anode. As pure water is a non-conductor of electricity, small quantity of sodium hydroxide will be added. Then current is passed till the volume is reduced to 1/6 the initial value. That is 6000 liters of water is reduced to 1000 liters by passing current. The resultant 1000 liters is shifted to second stage. Again the process is repeated. Like that, the process is repeated in 7 stages. At the end of 7th stage, 100% pure heavy water is obtained. Urey prepared 82 ml of pure heavy water beginning with 6000 liters of normal water. As the volumes of water to be processed are huge, the process is called as exhaustive electrolysis method. Now let us compare the physical properties of normal water with heavy water. Due to increase in molecular weight, most of the physical constant values of heavy water are higher than that of normal water, except dielectric constant value. Dielectric constant value is less for heavy water, while it is more for normal water. All other properties like melting point, boiling point, enthalpy of formation, enthalpy of vaporization, temperature of maximum density, viscosity are more for heavy water compared to normal water. Some of these physical constant values we have to remember, because based on these properties, some of the questions are coming in the entrance examinations. Chemical properties of heavy water. Heavy water gives same types of chemical reactions as that of normal water. Only difference is due to increase in the molecular weight, the rate of reactions involving heavy water will be slow. Most of the reactions can be represented like this, like electrolysis. When heavy water is electrolyzed, we get deuterium at a cathode, while oxygen is released at a anode. Just like water, heavy water also can break most of the compounds, and corresponding reactions are called as deuterolysis reactions. For example, when calcium carbide is made to react with heavy water like this, the bonds will split. We get CaOD taken twice plus C2D2. CaOD twice is called as calcium deuteroxide, while C2D2 is called deuteroacetylene or heavy acetylene. Similarly, when heavy water is made to react with aluminum chloride molecule will break down like this. We get AlOD thrice plus DCl. AlOD thrice is called as aluminum deuteroxide. DCl is called heavy hydrochloric acid or deuterochloric acid. When heavy water is added to compounds containing normal hydrogen, normal hydrogen is exchanged for heavy hydrogen. Say for example, if we add heavy water to hydrochloric acid, the normal hydrogen will be replaced with the heavy hydrogen. So we get DCl and HDO as the products. This DCl is called as deuterochloric acid and this HDO will be called as mixed water. Similarly, if heavy water is added to sodium hydroxide, the normal hydrogen is replaced with the heavy hydrogen. We get NaOD plus HDO. NaOD is called as sodium deuteroxide, HDO is called as mixed water. Then coming to physiological properties. Physiological in the sense, what is the effect of heavy water on the living beings? From experiments, it has been proved that heavy water is toxic in nature. When small fish and tadpole were released into heavy water, they could not survive. And germination of seeds also doesn't take place with heavy water. These reactions indicate the toxic nature of heavy water. So we can say physiological response of heavy water is it is a non-supporter of life. What are the uses of heavy water? Heavy water is used as a moderator in nuclear power plants. The moderator will decrease the speed of secondary neutrons produced during the nuclear fission reactions. Otherwise, the secondary neutrons will initiate a number of fission reactions which cannot be controlled, leading to chain reaction which leads to explosion. So, to control the rate of or speed of the secondary neutrons, this heavy water is used. That is its major application. Minor application is the heavy water is used to study the reaction mechanisms. Another important compound of hydrogen is hydrogen peroxide, H2O2. Let us see the preparation methods. These preparation methods are classified into two types as laboratory methods and industrial methods. In the laboratory, hydrogen peroxide is prepared in small quantities either by Marx process or by the action of mineral acids on barium peroxide. In Marx process, sodium peroxide is treated with dilute mineral acids. Reaction is carried out at low temperatures. You will get hydrogen peroxide and sodium sulfate as the products. This reaction is called as a Marx process. Alternatively, when barium peroxide is made to react with mineral acids at low temperatures, you can get dilute solutions of hydrogen peroxide. For example, when barium peroxide is treated with sulfuric acid or phosphoric acid or carbonic acid at a temperature of 0 to 5 degrees centigrade, exchange of ions takes place leading to the formation of hydrogen peroxide. When sulfuric acid is used, side product will be barium sulfate. When phosphoric acid is used, side product will be barium phosphate, while carbonic acid is used, side product will be barium carbonate. Out of the three acids, phosphoric acid's usage is advisable. Why? Because traces of phosphoric acid will stabilize hydrogen peroxide formed in the reaction. Whereas, if sulfuric acid is used, any traces left out catalyze the decomposition of hydrogen peroxide. Hence, the suitable acids for the preparation of hydrogen peroxide from barium peroxide are phosphoric acid and carbonic acid. By means of these reactions, Small quantities of hydrogen peroxide can be prepared in the laboratory. Coming to industrial methods, hydrogen peroxide is prepared on a large scale by two methods. One is called auto oxidation method and another one is called as electrolysis method. Preparation of hydrogen peroxide by auto oxidation method. In this method, we begin the process with this compound 2-ethyl anthraquinone. This compound is heated with hydrogen gas in the presence of nickel as catalyst. Keto groups are converted into alcohol groups. This compound is called 2-ethyl anthraquinol. When it is exposed to air, it undergoes oxidation, and in that process again we get back. In auto oxidation method, 2-ethyl anthraquinone is heated with hydrogen gas in the presence of nickel as catalyst. The keto groups are converted into alcoholic groups, and the resultant product, it is called as 2-ethyl anthraquinol. When 2-ethyl anthraquinol is exposed to air, it undergoes oxidation by reacting with oxygen present in air. In that process again we get back 2-ethyl anthraquinone and hydrogen peroxide is obtained. This is one of the most convenient method and efficient method for the preparation of hydrogen peroxide. In this reaction, this 2-ethyl anthraquinone can be taken as a catalyst. It is initially participating in the reaction, but at the end of the process is coming out unchanged. Electrolysis method. In this method, 50% concentrated sulfuric acid solution is electrolyzed to get hydrogen peroxide. In the electrolysis method, a hard glass tube is taken. It is wounded with lead wire that acts as anode. A platinum wire is placed inside. That acts as a cathode. In this hard glass tube, 50% concentrated sulfuric acid solution will be taken. The acid solution is kept in a freezing mixture, and then current is passed. The sulfuric acid solution undergoes chemical changes and produces hydrogen peroxide as per the following reactions, which can be studied under the heading of cell reactions. In cell reactions, first the electrolyte undergoes the process of ionization. Electrolyte here is sulfuric acid, which undergoes ionization as H plus and HSO4 minus bisulfate ion under the given conditions. At cathode, H plus ions are attracted, they gain electrons and will be converted into hydrogen gas, which will come out in the form of bubbles along the platinum wire. Then reactions taking place at anode. The anion bisulfate ion is attracted towards anode. Two bisulfate ions will be converted into H2S2O8 along with the liberation of 2 electrons. This acid is called as per-disulfuric acid. This per-disulfuric acid undergoes the process of hydrolysis in 2 stages. First, it is converted into H2SO5 known as per monosulfuric acid. In the next stage, that per monosulfuric acid further hydrolyzes to give hydrogen peroxide and sulfuric acid. The overall reaction is H2S2O8 plus 2H2O gives H2O2 plus 2H2SO4. The hydrogen peroxide is collected along the walls of the glass tube. However, it is mixed with sulfuric acid. In general, 50% of the acid is converted into hydrogen peroxide by this method. Properties of hydrogen peroxide. The chemical properties of hydrogen peroxide can be studied under 4 headings: oxidizing properties, reducing properties, acidic properties, and addition reactions. Hydrogen peroxide is an unstable compound, readily dissociates to give water and nascent oxygen. This reaction is catalyzed in the presence of mineral acids like sulfuric acid, metals like platinum, and rough surfaces, as well as presence of light. Hence, this hydrogen peroxide is stored in dark brown colored wax coated plastic bottles. In addition, to decrease the rate of decomposition of hydrogen peroxide, negative catalysts like ethyl alcohol, phosphoric acid, and acetanilide are added. The nascent oxygen released by hydrogen peroxide is the reason for oxidizing properties of hydrogen peroxide. Then, in the presence of stronger oxidizing agents than hydrogen peroxide accepts nascent oxygen and in that process gets converted into water and molecular oxygen. This is the reaction responsible for reducing properties of hydrogen peroxide. However, these reducing properties are called as pseudo reducing properties because in practice hydrogen peroxide is not accepting the nascent oxygen even though it appears to be. Hence, the reducing properties of hydrogen peroxide are called false reducing reactions or pseudo reducing reactions. The hydrogen peroxide reacts with active metals like sodium to give salt along with the liberation of hydrogen gas. Hydrogen peroxide can react with strong bases like sodium hydroxide to give salt and water. For example, hydrogen peroxide reacts with sodium hydroxide to give sodium peroxide and water. Based on these reactions, we can say hydrogen peroxide is slightly acidic in nature. Then, with certain organic compounds like urea, hydrogen peroxide gives addition products. A equimolar mixture of urea and hydrogen peroxide is known as hyperol. This hyperol is used as an explosive. Then coming to application part of hydrogen peroxide acts as a mild bleaching agent. It can bleach means it can remove the color of object without damaging it. Based on this property, hydrogen peroxide is used to bleach sensitive articles like hair, wool, silk and ivory. 100% pure hydrogen peroxide, it is called as perhedrol. It is used as a rocket fuel. And hyperol, an addition product of hydrogen peroxide, is used as explosive. These are the major applications. Minor applications are dilute solutions of hydrogen peroxide are used as antiseptics and as mouthwash. In this class, we have discussed methods for the removal of hardness of water, how to prepare hydrogen peroxide, what are the properties and uses, then how to prepare heavy water, what are its properties and uses. Let us see some of the previous questions that came in various entrance examinations based on this topic, hydrogen and its compounds. Which one of the following hydrate doesn't contain covalently bonded water? Given options are chromium chloride, hydrated copper sulfate, barium chloride and cobalt complex ion. Correct option is the third one, barium chloride dot 2H2O. Which of the following cause temporary hardness to water? Given options are sulfates of calcium and magnesium, hydrogen carbonates of calcium and magnesium, chlorides of calcium and magnesium, hydroxides of calcium and magnesium. The correct option is B. Bicarbonates of calcium and magnesium are responsible for the temporary hardness of water. 23rd question. Which of the following salts are responsible for permanent hardness of water? Given options are sulfides and chlorides of calcium and magnesium, hydrogen carbonates of calcium and magnesium, carbonates of calcium and magnesium, hydroxides of calcium and magnesium. Correct option is the first one. Sulfates and chlorides of calcium and magnesium ions are responsible for permanent hardness of water. During boiling of water containing temporary hardness, magnesium bicarbonate is converted into magnesium hydroxide, but calcium bicarbonate is converted into calcium carbonate. Reason is the solubility product of magnesium carbonate is more than that of magnesium hydroxide. That is why the reaction takes place like that. Correct option is B. 25. In Clark's method, chemical added to hard water to remove the hardness is milk of lime will be added in Clark's method, that is calcium hydroxide. So correct option is C. The formula of colgan is sodium hexametaphosphate is called as colgan. So correct option is A, Na6P6O18. 27th question. Zeolite is chemically known as sodium aluminum orthosilicate. So correct option is A. 28th question. Which one of the following is used for regenerating exhausted palmitate? Exhausted palmitate is regenerated by washing with a brine solution, that is aqueous sodium chloride solution. So correct option is B. Cation exchange resins used in removal of permanent hardness of water contain the groups of acidic groups are used as cation exchange resins. In the given options, the acidic group is sulfonic group, that is C. 30th question. Deionized water can be prepared by. The water obtained in ion exchange method is free from all types of ions. Hence it is called as deionized water or demineralized water. So the correct method is here two options are available, synthetic resin method as well as ion exchange method. Both can be taken as correct options. When water is passed through cation exchanger, calcium and magnesium ions are replaced with H plus ions. Hence, the resultant water coming out of the cation exchanger will be acidic in nature, and for acidic solutions pH value will be less than 7. So correct answer here is B, less than 7. 32nd question. Exhausted cation and anion exchange resin beds are regenerated respectively by. Cation exchanger is regenerated by washing with dilute sulfuric acid, and anion exchange resin is regenerated by washing with dilute sodium hydroxide. Therefore, the correct options here are B, dilute acid and dilute alkali. 33rd question, chemical formula of zeolite is. Zeolite or permeate is hydrated sodium aluminum orthosilicate. So correct option is A. The electrolytic oxidation of 50% concentrated sulfuric acid produces. During the electrolysis of 50% concentrated sulfuric acid, pyridisulfuric acid is formed at anode.